Okay, this is chapter 22 video for honors, and we're going to start with definitions. So in order to do 22, you have to understand some basic words. We're going to talk about oxidation and reduction in terms of electrons. So in terms of electrons, oxidation is a loss of electrons. So that would be like if copper turned into copper ion and some electrons fell off. Reduction is a gain of electrons. And that would be pretty much the opposite. If you had a zinc ion and you added some electrons, it would turn into a zinc metal. In terms of charge, oxidation is a gain in charge. For instance, if Cl minus turns into Cl neutral, it went from -1 up to neutral 0. A reduction is a lowering or reducing of charge. So that could be, once again, you have the zinc and it turns into a zinc. And you'll notice that these actually agree with each other. They never conflict each other. So I just left the electrons out because the focus of this definition was charge. Then there's oxygen. This is the original way that we came up with the words oxidation reduction. So it will make the most sense with that vocabulary. So oxidation is a gain of oxygen. So that'd be like SO2 becomes SO3. And reduction is a loss or reduction of oxygen. So that could just be the reverse. You have carbon dioxide turning into carbon monoxide. These oxidations and reductions are not included in this oxidation reduction reaction, which is why even though this is the original one, it's not as useful anymore. So scooching on. Looking at these, we want to be able to quickly look and figure out if something is an oxidation or reduction. So identify the following as a reduction or oxidation reaction. Well, lithium is turning into an ion and releasing an electron. So when you release an electron or you lose an electron, we call that oxidation. So anytime electrons are on the product side, it's oxidation. Vice versa, anytime the electrons are on the reactant side, we would call that a reduction. So this is labeling it, focusing on the electron definition. Well, let's try focusing on the charge definition. In this one, what is being oxidized and reduced? And label the oxidizing and reducing agent, which I'll show to you right now. So, we're going to focus on the charges. Focus on charges. So sodium by itself has a charge of 0, and you know this, it's neutral. Sulfur by itself has a charge of 0. And reviewing, when we put it together to make the compound, sodium's in the +1 column, and sulfur is in the -2 column. So what happened is the sodium metal turned into a sodium ion. So it looks to me like the sodium lost an electron. Therefore, a loss of electron is oxidation. If sodium lost an electron, someone must have picked that electron up. It looks like sulfur went from 0 up to -2, so sulfur gained 2 electrons in this case. So we would say sulfur is reduced and sodium is oxidized. Now, it always flips. If sodium was oxidized, then sodium is the reducing agent. Because by being oxidized, he allowed sulfur to be reduced. So he's the agent of reduction. Since sulfur was reduced, he will automatically be the oxidizing agent. So when sulfur gained 2 electrons, he allowed someone else to be oxidized or lose electrons. So that's why he's an oxidizing agent. Let's try another one. First, we're going to look at the charges. Aluminum by itself in nature is just a 0. Oxygen by itself in nature is also neutral. Aluminum as part of an ionic compound is in the +3 column. And oxygen as part of an ionic compound is in the -2 column. So we look again. Aluminum is going to lose 3 electrons. So aluminum lost 3 electrons. So we would say aluminum is oxidized. This is just my thoughts. So aluminum is oxidized. Therefore, oxygen gained 2 electrons. So oxygen was reduced. Doing the flip again, aluminum was oxidized, therefore aluminum is the reducing agent. Oxygen was reduced, so oxygen is the oxidizing agent. And there's one little trick here. When you write the agents, you want to write the formula as it appears on the reactant side. Up here, sodium really showed up as sodium. Sulfur was just boring sulfur. Aluminum was boring aluminum. But oxygen was part of something larger, so we're going to put the entire formula. And that is the end of just definitions.